So if we're going to use software as one of the key pieces that we want to have in our bundle, let's call it a research object, because that's what I call it. Let's not call them papers anymore. Let's call them research objects. The narrative, the data, the software, the infrastructure needed to actually really describe the experiment that you actually did, or the finding that you actually had. So if you're using software, software has traditionally not had an identifier, as it were, that you could point to and identify in the same way that data has recently, with the DOI idea, DOIs for data and DOIs for documents. Actually, software has had a notion of being open and having well-prescribed release cycles and controlled version management and control and release management around it for decades. So the open software community has understood the notion of collaborative open development and available software. And I would say that we're better at it than the database people are, because we know that software evolves. So we've had to deal with that. So we know the difference between pointing to a piece of software archivally, because you want to replicate what you did, and pointing to a piece of software that is the most recent version, because you don't care about replicating, you care about using the latest piece of software, which is the thing that's referred to in the paper. Quite different things, because citations, which is what this is about, identifiers are to do with citing. Citations are have two properties. I'm citing it because that was evidence that defends my claim, and I'm citing it because that's where you go get it. And these are two separate things in software. So we know about that. We've had techniques of being able to get hold of software for a long time. Now, of course, we have to bring it into the publishing world. So there are efforts to allocate DOIs to software. And the most notable one is software as a research, code as a research object, which is an initiative by GitHub in partnership with Figshare and the Mozilla Science Labs. And that is explicitly doing this, of allocating identifiers to software that is packaged in the GitHub repository. And so we already have a platform that you can use for exactly this job. So I think once the technical stuff, we can actually do. It's the cultural stuff that's a bit harder. We've discussed this many times at major conferences, particularly BOSC, in Associated Conference for Open Source Software in Life Sciences, that goes along with one of the big conferences in bioinformatics. And the killer is that it's difficult to get software going. So there's a classical tweet on overly honest methods, and by a guy called Ian Holmes, I think, if I remember well, which says, "We say our software is openly available from this URL. Good luck with downloading the only PhD student who can get it to run." And that basically sums it all up. So it's one thing to make things open and available, open source. Here's an identifier to it. Good luck, here it is. And getting the flipping thing to work. With all of the library dependencies and everything else. This goes back to the portability aspect. So the responsibility of the reviewers is, A, can I get hold of it? Is it still there? And B, does it work? And the work is really tricky. So I think from the point of view, at the point of accepting a paper and check its soundness, we can do something with things like virtual machines or hosted systems. GigaScience takes a hosted systems approach where you put it into this hosted system and then you can run the protocol there, the software there. Others say you package up a virtual machine, and then if that works, at least you can see that it works. That's not the same as porting it and being able to see what the code actually does. But at least it's a step so that you can run what was there. And I think we'll end up with expert reviewers, and we'll have to think of how to leverage the one class of reviewers who really can get software to work, which is postdocs and PhD students. So we've toyed, for example, of a multi-tiered review where you get postdocs and PhD students to get the software going so that then somebody else, perhaps, who's more experienced in the science, then can use it to do the science. So you have paired review, you have a technical review, and you have a scientific review. And there'll be two different kinds of people doing that review. And they'll get equal status in that review. And we can use that status in order to incentivize people to do it. So there's been discussions around those ideas. There are very good practices for documenting code, for porting code. I'm a member of the Software Sustainability Institute in the UK, which advises people how to do this. There are very good principles for how to do this. The trick is to get it out into the community, and particularly a community where, frankly, the software isn't their prime focus. The software is a mechanism in order to be able to do their science. It's different if it's an informatics journal. If it's bioinformatics, the software is key to the results. But if it's a biology journal, cancer journal, the software that was used was incidental in their minds to the results, but it's critical to being able to replicate the results, and it's critical to be able to review the results. And it's often written by people who were not software engineers. So most of the time the software is written by people who are not software engineers and don't actually know how to make it usable by somebody who isn't them. That's the difference between a software engineer and a hacker. A hacker, it works for them today. Software engineer, it works for somebody else tomorrow and the next day. And that kind of discipline is considered, well, as long as it works today for me and I got my results out, that's all that matters. So I think there's a bit of a cultural change there. So they should know about, in the life sciences, they should know about biosharing. So biosharing is an initiative that lists all of the metadata standards for data management. So it's part of the community on how should I describe my data so it should be interoperable and exchangeable and can be intelligible by others. So that's an important one. The second one is the software carpentry is a big initiative. Software carpentry is a grassroots community started in the 1990s, which has really taken off. It started in the life sciences, and software carpentry is a volunteers network for going into laboratories and doing boot camps for people who use software, who build software, but were never software engineers. And it teaches them the basics, version management, regression testing, understanding how to really make software sound enough, good practices of software. And it's taught to what you might call researcher software engineers as opposed to professional software engineers by researcher software engineers. So it's by the people, for the people, as it were. And so that's a critical community, and I know about that one because the Software Sustainability Institute in the UK are agents for software carpentry in the UK, and we could give a software carpentry boot camp every day if we took up all of the requests. So there's a real appetite for that. So that's metadata. That's a sort of food biosharing and software. And I guess the third initiative, I would say, is a more of a political initiative, which is Force 11. So Force 11, as I said at the beginning, is a community sponsored by the Sloan Foundation, a not-for-profit, that brings together digital libraries. It brings together computer scientists, infrastructure providers, data, what might I call data carpentry people. Like we have software carpentry, we can have data carpentry as well, training people how to do data curation. It brings in publishers to try to collectively work on how to share best practices for new models of scholarship. And they're particularly working on how do we do data citation and how do we do software citation. And without citation being built into this process, we'll never really get the impetus that we need, because we know people are driven by incentives, and incentives mean citations. So we have to build data and software tracking platforms in order to be able to give people the kind of stars that they need in order to be able to put in front of their review committees, journal review committees, funder review committees, promotion committees.